I would hate to get all the way through and not have it recorded. So,
and there we are. We're back.
So just for our teacher, I'm sorry, my computer died, so this is the second half. Okay, so number 10. How does it, oh, we already read it. So I just put the larger the sample size, the smaller the margin of error.
Yeah.
I'm not sure what. Is that what you got, right?
Yeah, the bigger the sample size, the smaller the margin of error.
Okay.
Create a 90% confidence interval for 50 students.
It's a 90%. Instead of 1.96, it'll be 1.645.
Right. So we're just 1.65 times. And we're still using the same information on this one, right? The 32 over square root of 50.
For the original 50 students, yep.
Yeah. So I got a margin of error of 7.47.
Okay, sorry, I'm still calculating. Okay, times. Okay, you got what?
I rounded it to 7.47.
Okay, I got something really different.
Oh, okay, what did you get?
I got 11.63. So let me redo this again really quick. So the square root of 50 is 7.071, right?
I don't know. I just plugged it all into my calculator.
Okay.
So I got 1.65 times the 32 divided by the square root of 50.
Okay, sorry. You got what?
I did 1.65 times 32 divided by the square root of 50.
Okay.
I wonder if he didn't round, because my answers are close to what they've gotten their answers, but it's not quite 100% the same. So.
Okay.
Wonder if he did this.
I got 7.445. For the margin of error.
And okay, so he didn't. So 7.445. How are we getting different answers?
I don't know. So the one for the lowest, I got 533.56. And then for the top one, I haven't done that one yet.
So are you rounding the Z-score?
No, the Z-score, I'm leaving it at 1.645.
4.5. Yeah, that's what I rounded because I did some rounding earlier. But that gave me
how I've understood it is you do it to the 3 decimal points. And that's how I compute everything with 3 decimal points. And then if at the end it says round to the nearest hundredth, then I move it up.
Yeah. So you got 7.445, you said, as the margin of error?
Yes.
Because when I do this, I come up with 7.444420,192.
Okay. So for the
But
square root of 50, I got 7.071 is what I used.
yeah.
So then 32 divided by 7.071 is 4.5255. So I put 4.526.
Yeah.
And then that times
1.645.
yes.
So yeah.
And that's how I got the 7.44527.
Yeah, I see that.
Okay.
So I just plugged it all into my calculator all in one thing, and it did its all.
Okay.
Whatever. Okay, so let me do 1.645. Okay. So now I got the same answers as you. That's
Okay.
So what'd you get?
For 11?
What'd you get for the other part of for the second part? Is that the one number we're on right now?
For
the second half of 11.
548.45.
Okay, I got 548.44. I mean, like I said, close. On the answer key, it says 44.
Okay. My answer is actually 5.48.445. So that's why I rounded it to 5.
Yeah, mine was 5.548.444.
Okay. I'm not sure how I got the 5 in there. But that makes sense. Okay. All right. And then 12, I just said the margin of error for 90% is, wait a second. I got that it was.
Okay, how does the margin of error for 95% confidence interval that you compute in question 8 compare to 90%? Well, the margin of error gets smaller for the lower confidence interval.
Oh, the margin of error. Yes, it does.
Yeah.
I was thinking the overall numbers, and I was like, they didn't really, one got smaller, it just like shifted. So instead of being at 34 and 47, it was at 33 and 48. So that makes sense, the margin of error. That number definitely got smaller.
Yep. Yeah. Okay. The BYUI professor would like to repeat the experiment, but he wants to make sure he has enough students in his sample to ensure that his margin of error is 5. How many students will need to be in his sample to ensure that he has this level of accuracy for a 95% confidence level? So this just kind of...
This is, okay, so if you look at, it says 5 sample size calculations. There is a calculation for finding the sample size. So
there we go. So it's n equals the z-score times that over the
m, the margin of error. So the margin of error for 95% was 8.87, right?
Well, that was... But with that, we had our sample size with that. Here we don't have the sample size. We're trying to figure it out, right? Because to find the margin of error, we had the sample size of 50. Well, we know 50 is not it.
Oh, that's true. Shoot.
You know what I'm saying? So we got to figure out the z-score is 1.945, 1. So we're looking for 95%, 1.960.
Yeah.
Is our z-score. The squiggly O, whatever. Okay. So n equals 1.960 times whatever our squiggly O is. See, that doesn't...
32 is...
Times, that's right, 32 over the margin of error, which we want to be 5, right? Which is 1.960 times 32 divided by 5. No, that doesn't... Doing something wrong. Sample. The trick to solve the margin of error is to solve the margin of error equation. This gives us a sample size, which tells us the number of observations required in order to obtain a specific margin of error. Once the level of confidence is selected, this is automatically determined. Okay. Use the process of guessing check. I mean, the reality is we could guess and check this thing, but
yeah,
we should. Because, or shoot, we know it's got to be more than 100.
Mm-hmm.
Let's see. Okay, let's see. Oh, wait a minute. Oh, I'm leaving something out. That's my problem. Squared.
Oh, that's right. And then you square it, right?
That's what I was leaving off. Yes. Then we square it, which equals 150. I have 157.352. So we need greater than 157.
So
Is that what you got?
I got 157.35, and then you just round up, right? So 158.
Round up 158. Yeah. One simple little thing took me like 5 minutes to figure out.
That's what I was thinking. I was like, I feel like I'm doing it just like it's telling me to, and it's not working.
12 is way off. What the heck?
Yeah.
And in the answers, 158 students.
Perfect.
Sweet.
All right, you ready to do the quiz now?
Let's go to it. All right, start. I did that. I'm here. Okay. Number 3. Find the margin of error for a 90% confidence interval when the standard deviation is 50 and n is 25. 90% is 1.65 or 645 times 50 over the square root of 25. Okay. Round to 3 decimal places. Do this. All right. I've got an answer.
Me too.
16.450.
Yep. Yeah. That always throws me off because I always I just got 16.45 and I just want to put 16.45 and I'm like, oh wait, 3 decimal points, 0.
You gotta add that one, I guess. All right. Which of the following statements is true? All right. Is it A?
Is a point estimator of.
Now all of a sudden I'm blanking on what a point estimator versus an interval estimator is.
Actually, I think it is A.
That's what I was
Because
thinking.
the point estimate is the mean for the other one. So yes, U is.
Right?
So the mean is the point estimator of X. Yes.
Yeah. You know, it's a constructive standard point of sample size and X is 526. Use the what is the lower limit level? So we got 95%. 96. So we need to figure out the margin of error first.
Yeah.
Right?
Yes.
Okay, 1.96 times that over square root of that. Oh. Okay.
I got the margin of error is 27.685.
That's what I got also.
Okay, and then you just subtract it from the mean. right? So the 526.
So here, we're going 3 decimal places. Okay. 498.315.
Yep, that's what I got as well.
The upper, okay, so then we add. $553.685.
Yep.
Okay. What would happen to the width of the confidence interval if Gina increased the sample size?
It would decrease, right? Get smaller.
The width of confidence interval. The larger the sample size, the lower the margin of error.
Yeah. And the smaller, so if it's the lower the margin of error. Hey, stop it.
Yeah.
Oh my goodness. Right over there. Okay, what would happen to the width of the interval if Gina changed it to 99? It would increase, right?
I believe so. Okay. 100 hours. They want a 95% confidence interval with a margin error of 50 hours. Okay, so n equals the standard deviation. Okay, wait, 95%, 1.96 times the standard deviation of 400 or 50, and then we got to remember to square that answer.
Yeah. I got 245, 246.
246, that's what I got also.
Okay. Okay, so just...
What is the lower limit of the 95%? Round to the nearest whole number. So we take 96 times the standard deviation, 36,730 over.
Is it, okay, you collect a simple random sample of, okay, wait, so for this one, because it's a sample of the sample, is this the one where, do you remember the last lesson where you had to do,
Oh, shoot. Now we're going back to the last lesson. Okay.
I'm trying to remember, because it says the mean is 100,000, standard deviation is 36, but that's the standard deviation of the 100,000. So we have to find the standard deviation of the, okay, wait. It says you collect a simple random sample of 36 and find that the mean is 111,000. So we have to find the standard deviation of that, right?
Of that 111?
Yeah, and 36. Right?
Okay. Of this 95%. So we're trying to figure out the mean salary for women is different than the population mean. So up top we have the population mean.
Mm-hmm.
Down here, this is the women's mean, 111. Yes, I believe so. So we take our 1.96, which is the confidence interval, and figure out that's our z-score. So we take the 111, or do we find the standard deviation out first off of the 111 and 36?
I think we have to find the standard deviation out first.
Okay.
So, and that is the x minus u over standard deviation. So, okay, wait, just kidding.
That's fine.
So the distribution of sample means, so is it a distribution of all possible sample means for a particular sample size? It has a mean of u and a standard deviation of the standard. Okay, so the standard deviation is 36,730 divided by the square root of 36. And that's going to be the standard deviation for.
That's right. I had to remember that stuff. So I got 6,121.667.
Okay, I haven't gotten anything yet.
Oh, okay.
You got 6,121.667, right?
Yeah.
Okay.
So that's our standard deviation for these 36.
Uh-huh.
So now we take 1.96 times 6,121.667 over 36. Right?
Sorry. Yes.
Or over the square root of 36.
Yeah, I think it's the square root of 36. My computer's being really slow right now. I'm sorry. I will do this on my husband's computer next time because this one obviously isn't working. All right, I got 1,999.744 for the margin of error.
Yes, that's what I got also. So then we take the 111,000 minus our answer, right?
Yeah, because it's asking the lower limit. I got 109,001.
Well, if we're rounding to the nearest whole number, we always round up.
Yes. So if there's any decimal points,
then we always round up, right?
Yeah.
So
yeah, the way I understand it is, you can't do like a 0.2% of a person, so you always just add a whole other person. So rounding up from that.
Yeah. Okay, so then I take.
So I got 113,000 for.
Yes.
All right, last one. Woo! There are 3 requirements that need to be checked for computing the mean. They are all of the above.
All of the above, yeah.
Bam. All right, you ready to submit?
You know, this number 12 was kind of funny. It's asking for 3, but you can only select one answer. So it's got to be all of the above, whether you know it or not.
Yeah.
Because each one only gives you one answer. It's just kind of funny. Yeah, submit.
All right.
Oh.
What?
Number 4. How are we wrong on these ones?
Oh, that one's just X. Okay, so darn it, that one is backwards. So X is the point estimator of U rather than. So
U
U
of
is
X.
the mean, X is the point estimator. That's dumb.
Doggone it.
I feel like we knew that one, and it was just like a trick question. And then 10 and 11, are you kidding me?
I wonder if we did too much work.
I wonder if so, too. So do you just use the standard deviation for the normal one?
That's what I'm wondering. If we should have just used the standard deviation that they had already figured out and just did that 1.96 times the 36,730 over square root of 36.
Yeah, that's dumb because in the past, you'd think you'd use the past lessons to where this is like the exact same thing as the past lessons, except for you're finding the 95 confidence interval rather than the z-score or whatever.
Yeah, doggone it.
That's dumb. Well, sorry about that. That one was totally my idea.
Oh, well.
All right. Well, I will see you on Thursday. And we'll do better next time.
All right.
All right. See you later.
See ya.
All right.